So welcome back students. In the previous video we have seen the definitions. That is number one is polynomial. We have discussed about the polynomial. We have discussed about the algebraic equation. We have discussed about the transcendental equation, and we have discussed about the properties of polynomial equation. That is fundamental theorem of algebra and intermediate theorem. So now we are going to see the four models. So today's class we are going to see the four models. So now I am going to start the first model, that is bisection method. So this bisection method is also called as Bolzano method, or interval of interval method, or interval halving method, or Bolzano method of successive approximation, or simply it is called as simple iteration method. So this method is having many names. So you can call by any name we can easily identify it. So this method is called as bisection method. We can call, or we can call as Bolzano method, or off interval method, or interval halving method, or Bolzano method of successive approximation, or simple iteration method. So now we are going to see this method. So this method is based on repeated applications of intermediate value theorem. So this is based on intermediate value theorem. We already know about the intermediate value theorem. So that is, if f of x is continuous on closed interval a b, and f of a and f of b have opposite signs, then root lies between f of a and f of b. That means if f of a less than 0 or f of b greater than 0, then root lies between a and b. Or f of a greater than 0, f of b less than 0. Or f of a less than 0, f of b greater than 0. Then root lies between a and b. So this bisection method is a simple iteration method. So this is the very simple method to solve the root of an equation. So based on all the other models or all the other methods, we can say that this bisection method is a simple iteration to solve the root of the equation. So this is about the just introduction about the bisection method. So this method is also known as Bolzano method, or interval halving method, or off interval method, or Bolzano method of successive approximation, or simple iteration method. So now we are going to see the working rules and the merits and demerits of this method. So the merits and demerits are, this method is very simple and easy to calculate. So easily we can calculate. That means it is very simple. That means calculation is also very simple. This method is based on intermediate value theorem. So this is also one of the, we can say that this method is very simple and easy to calculate. So this is a merit, we can take it as merit. This method is based on intermediate value theorem. So we can take it as demerit. Why? Because it is based on the intermediate value theorem. It is based on some theorem. So we can consider it as a demerit also. So this method requires a starting two values, that is a. So without these two values, we cannot do the problem. So this is one of the demerit of this method. So without this a and b value, we cannot do the problem. We cannot even continue the problem. So this is one of the demerit of this. The accuracy of the roots may be different. Accuracy in the sense, each and every student may get different answers. That means accuracy is different. And this means based on the roots, he can get the answer. So if one student takes the roots between 1 and 2, then he will get the answer between 1 and 2. If a student takes answer between 2 and 3, then we will get the answer between 2. So that means the accuracy of the roots may be different for student to student, or if we can do different models, so different roots can be taken. So the accuracy may be different. So this is also one of the demerit of this. So these are the four merits and demerits of the bisection method. Then the working rule is, so here we already know that this is the formula for bisection method. So that is average between a and b. That is the first approximation formula in this method is x1 equal to a plus b by 2. So this is the formula for bisection method. If f of x1 equal to 0, so if the polynomial f of x1 equal to 0, then x1 is the root of the equation and we stop the remaining process. That means our problem is completed. So f of x1 not equal to 0, if f of x1 not equal to 0, then two things can happen. That is, either f of x1 can less than 0 or f of x1 can greater than 0. Suppose f of x1 greater than 0, then the root lies between a and x1. Then the second approximation formula is x2 equal to a plus x1 by 2. Suppose if possible, if f of x1 is less than 0, then the root lies between x1 and 2. Then the second approximation is x2 equal to x1 plus b by 2. So this is about the working rule of the bisection method. So in the first, the formula for bisection method is x1 equal to a plus b by 2. If f of x1 equal to 0, then x1 is the root for the given equation and we stop the remaining process. If f of x1 not equal to 0, then the two things may be happen, that is either f of x1 is less than 0 or f of x1 is greater than 0. If f of x1 greater than 0, Then the root lies between a and x1. Then the second approximation is x2 equal to a plus x1 by 2. Or if f of x1 is less than 0, then the root lies between x1 and b, or then the second approximation can become as x2 equal to x1 plus b by 2. So this is the working rule on bisection method. So now we are going to see the problems. So here I have written a simple process. If f of x1 not equal to 0, then f of x1 less than 0, f of x1 greater than 0. Then root lies between x1 and b, and here the root lies between a and x1. So here we continue this process until the required root is obtained. That means we continue the process until the two roots are approximately same. That is, two consecutive roots are approximately same. Then we stop the process. So we stop the process until two roots are approximately same. So this is the working rule of a bisection method. Suppose in the examination, if you ask about the working rule of a bisection method, you simply you have to write these steps. So these are the very important and easy steps to write. So this question also he may be asked in the examination. So he may ask what is the working rule of a bisection method, or explain briefly about the bisection method. Then you can write this. So now we are going to see the problem. So I have done some problems here for you. So the first problem is find the positive root of x cube minus 4x minus 9 equal to 0. So this is the first problem. Using bisection method corrected to 4 decimal places. So here we have to use our scientific calculators. Why? Because without scientific calculators we cannot do these problems. So scientific calculators are very important to do these problems. So he has asked to take to consider about the 4 decimal places. That means we have to take the calculator. We have to see the calculator and we have to convert the calculator by 4 decimals. That means at last we have to get the answer based on the 4 decimal points. That means after point we have to get the four decimals. So that calculator is very important. Scientific calculator is very important while doing these problems. Without scientific calculator, we cannot even touch this problem. So here now I am going to solve this problem. So here he has given f of x. So we have to take all the values. So I have taken f of x place in place of x. I have taken 0, that is less than 0. F of 1 I have got less than 0, minus 4, that is less than 0. I have taken f of 2, that is less than 0. I have taken f of 3 greater than 0. That means here f of a is less than 0 and f of b is greater than 0. Therefore, the root lies between a and b. So in place of a I am having 2, in place of b I am having 3. So the root lies between 2 and 3. That is a is 2 and b is 3. So next I already know that the first approximation is x1 equal to a plus b by 2. So first approximation, I have written the first approximation formula. So in place of a I have written the 2, in place of b I have written the 3. So 2 plus 3 by 2, that is 2.5. So x1 equal to 2.5. So now what I have to do is I have to take this point x1 equal to 2.5. I have to convert this point into the given equation. So I have to use this point in the equation. So f of 2.5 equal to 2.5 cube minus 4 into 2.5 minus 9 equal to 0. So I have to use this 2.5 in the given equation. So then I got minus 3.3750. So after point I have taken 4 decimals. Why? Because we are said to take the 4 decimals. So I have taken the 4 decimals. So this is less than 0. So here f of x1 is less than 0. So 1 is less than 0. Next what we want is other one what we have to want is greater than 0. So I will go for the up. I will see up where it is greater than 0. So here by seeing here I have f of 2 is less than 0 and f of 3 is greater than 0. So greater than 0 means f of 3 is greater than 0. So I have to take that. So I have taken f of 3 greater than 0. Why? Because the intermediate value theorem says that if 1 is less than 0, then other should be greater than 0. Then only the root lies between a and b. So I have taken x1 and 3. So the x1 value is 2.5 and b value is 3. Therefore, the root lies between 2.5 and 3. So this is the x1 value and this is the b value. Next again I have to take second approximation. So x2 equal to x1 plus b by 2. So again I got 2.75. I have to see that whether x1 and x2 are same or not. If these both are same, then I have to stop the process and that is the root for the given equation. So these both are not same, but they are nearer. We have to see how much nearer they are. So nearer value is needed. So I have to take this f of x2 value, that is 2.75. I am substitute in the given equation. Next I got 0.76796, that is greater than 0. That means I got f of x2 greater than 0. Next here I am having greater than 0. Next option is I want less than 0. So I go for So we have to go for only one step. That means should not go for the starting of a problem. We have to only consider about the first step, only up step. So here I can see that f of x1 is less than 0. So I am having a 1 is greater than 0, I want 1 is less than 0. So f of x1 less than 0. Then the intermediate value says that if f of x1 is greater than 0, f of a is greater than 0, f of b is greater than less than 0, then root lies between a. So similarly here the root lies between x2 and x1. So I have to take another iteration x3 equal to next x1 plus x2 by 2. So similarly I got 2.625. So I will see that whether x1 and x2 are equal or x2 and x3 are equal or not. So these two are slightly different. So I have to go for the other equation. So I have taken the f of x3 and substitute the x3 value in the given equation. Again I got minus value. So less than 0. So f of x3 is less than 0. Now I want greater than value. So I go upwards. So here f of x2 is greater than 0. So one is less than 0 and another one is greater than 0. So the root lies between x3 and x2. So next I will go for the fourth approximation. So x4 equal to 2.6875. So f of x4. So I have to substitute this in the given equation. So now I got f of x4 is less than 0. So I got less than 0. So I will go for the greater than 0. So up I am having f of x2 is greater than 0. So therefore the root lies between x4 and x2. That is 2.6875 and 2.75. So next I will go for the other iteration. So I will see that whether suppose x3 and x4 are same or not. So x3 I am having 2.625 and x4 I am having 2.6875. So these are slightly different. So there is no equality between them. So I will go for the other iteration. So in the next iteration, so that is the fifth approximation, I got 2.7188. So these x4 and x5 are both are different. That means both are not so near. So I have to go for the other iteration. So here I have taken the value 2.7188 in the given equation. So that is greater than 0. f of xy is greater than 0. So now I want less than 0. So I have seen that f of x4 is less than 0 in the upper. That means we have to go for just for one step, not for the starting of the problem. Just we have to go for the other. So f of x4 is less than 0. Therefore, root lies between x5 and x4. So next I will go for the sixth approximation. So in the sixth approximation, I got 2.703. So now I see that the fifth approximation and sixth approximation values are approximately same. Now I should stop the process. Why? Because these two are slightly different. So you can observe from here I am having xy is 2.7188 and the x6 is 2.7035. So these are two are approximately same. So therefore my problem is completed and therefore the root for the given equation is 2.7035. So this is the answer for the given problem. So my problem is completed. So this is the problem on bisection method. So next I am going to take another problem. So here also he has asked the positive root. So x cube minus 3x square plus 1 equal to 0. So the first step what I have to do is I have to take the positive roots. That is here I have taken f of 0 value, f of 1 value. So some students may ask whether I should take consider from 0 and 1 only. So no need, you can take 1 and 2 or 2 or 3, whatever the root you want you can take. So based on that root only you will get the answer. If I take the root from 0 to 1, then I will get the answer between 0 and 1. If you take the root between 2 and 3, then you will get the answer between 2 and 3. So this is the important point we have said that the accuracy will be different. So the accuracy is based on the roots. So what we are taking. So that is the important point we have to observe. So here f of a is greater than 0 and f of b is less than 0. So the root lies between 0 and 1. Now I will take for the first approximation. I already know that the formula is x1 equal to a plus b by 2. So I got 0.5. So I have put this value in the given equation. Next I have f of x1 is greater than 0. So I will go for the one step and I will see whether which is less than 0. So here f of 1 is less than 0. So f of a is greater than 0, f of b is less than 0. Therefore, the root lies between a and b. So next I will go for second approximation. So again I am having second approximation value is 0.7500. So x1 is 0.50, x2 is 0.7. These two are different. So similarly, I will go for the other option. Why? Because these two are different. I have the accuracy of the roots may be different, but here the roots must and should be approximately same. So these two are not same. So I will put this value in the given equation. So next f of x2 is less than 0. So I want one greater than 0. So I will go for up. That is f of 0.5 is greater than 0. So therefore f of a less than 0, f of b greater than 0. So root lies between a and b. So next I will go for the third approximation. I have 0.625. So I can see that x2 and x3 are not approximately same. So I will put this value in the given equation. Next I have f of x3 greater than 0. So I will go for less than 0. F of x2 is less than 0. So therefore the root lies between 0.75 and 0.62. Now again I will take the average. So x4, again I am taking the average. So here also the value is different. So f of x4 is less than 0. So I will go for greater than 0. So f of x3 is greater than 0. So the root lies between 0.65 and 0.62. So next I will go for the fifth approximation. So here xy equal to 0.6563. So I can see that these two are slightly different. So I will go for the other approximation. So if you want, you can solve the problem. Otherwise, you can go for the other approximation. If you go for the other approximation, the value may be nearer. So that is the important point you have to remember. So based on the more iterations, you can get the value nearer. So that is the important point we have to remember. So in the first fifth approximation, we have xy equal to 0.656. So I have substitute the value in the given equation. So f of xy is less than 0. So I have to take from greater than 0. F of x3 is greater than 0. Therefore, the root lies between 0.6563 and 0.62. So next I will go for the sixth approximation. So in the sixth approximation, I have 0.6407. So here, if I want to stop, I can stop here. Otherwise, I can go for the other iteration. So here I have stopped. Why? Because these two values, the x5 and x6 both are approximately same. So I have stopped the process. So I see that x5 and x6 are approximately same. Therefore, the root for the given equation is 0.646. I have stopped the problem. So if you want, you can do the approximations, different approximations. So if you do plenty of approximations, then you can reach the nearer root. So this is the important point you should remember. So based on the time given, you have to take at least 5 or 6 approximations. 6 approximation, 5 or 6 approximations is needed in this method. So in the other methods, you can do the sum iterations, but in the bisection method, if you do many approximations, then you can find the root easily. That means the root will be nearer to the given value. So this is the important point you should remember. So next I am going to see the third problem. So here also he has asked to find the positive root of the equation corrected to 2 decimal places. So I have to fix the calculator to 2 decimal points. Why? Because he has asked to take the 2 decimal points. So same, I have taken f of x and I have taken the values. So here f of 1 is less than 0, f of 2 is greater than 0. Therefore the root lies between 1 and 2. So the first approximation formula, we have to write this, we have to mention this formula. So x1 equal to a plus b by 2, x1 equal to a plus b by 2, 1 plus 2 by 2, that is 1.5. So I have to put this value in given equation. I have got f of x1 greater than 0 and I must and should have less than 0. So by seeing up step, I have f of 1 is less than 0. Therefore the root lies between x1 and 1. So that is x 1.5 and 1. So next I have gone for the second approximation. That is I got 1.25. So I have to see that whether x1 and x2 are approximately same. But these two are different. So I have to substitute this value in the given equation. So again f of x2 is less than 0 and I have to see for the greater than 0, f of x1 is greater than 0. Therefore the root lies between 1.25 and 1.5. So next I will go for the third approximation. I have 1.37. So these x2 and x3 are so different. So I have to go for the other approximation. So why? Because these two are very different. 1.25 is different from 1.37. So I have to continue the other iterations. So I have put this value in the given equation. I got f of x is greater than 0 and I should want I want f of x one less value. Why? Because I am having greater than value, I should have the less value. So f of x2 is less than 0. So therefore the root lies between 1.25 and 1.37. So next I will go for the fourth approximation, 1.31. So these two I can observe that x3 and x4 are slightly different. So if I want, I can stop this process. Otherwise, I can go for the other approximation. If you do plenty of approximations, or at least 5 approximation, so then you can get the exact answer. That means you can reach the exact answer. So I have gone forward for the other approximation. So here x5, I got 1.34. So next I have to not put the value in the given equation. Why? Because here I can see that x4 and x5 are approximately same. Why? Because 1.31 and 1.34 are approximately same. So if you go for the other iteration also, we will get the same answer. That means slightly different. So I have to stop this process. So if you want to continue, you can continue. Otherwise, you can leave this problem. So you can see that x4 and x5 are approximately same. Therefore, the root for the given equation is the last value, 1.34. So I stop this problem. So the problem is solved. So if you want to continue, you can continue. The value will be slightly different. So based on the time, you can do the iterations, but maximum number of iterations you have to do in this bisection method is 5 iterations. So 5 iterations are needed to do this problem. So based on 5 iterations, you can decide the answer. So based on 5, you can decide answer. Or if you are having many more time, then you can go for the other iterations also. Or otherwise, you can simply decide the answer. So next, similarly, I have taken here the transcendental equation. I have taken the logarithmic value, and similarly, I have seen that f of 2 is less than 0 and f of 3 is greater than 0. Therefore, the root lies between a and b. So the first approximation is x1 equal to a plus b by 2. So the value is f of x1 is less than 0. I have gone for the greater than 0. Therefore, the root lies between 2.5 and 3. So I have gone to the second approach, that is x2 equal to 2.75. So I have to see that x1 and x2 are not approximately same. So I have to substitute the values in the given equation. So f of x2 is greater than 0. So I have in the above step I have f of x1 is less than 0. So f of x1 is less than 0. I have to take that. So 1 is less than 0, 1 is greater than 0. Root lies between 2.5 and 2.75. So I have substituted this value, and next I got the third approximation x3 equal to 2.625. So f of x3, if I substitute the value in given equation, then I got f of x3 less than 0. In the above step, I have f of x2 greater than 0. Therefore, by intermediate value theorem, I can say that root lies between a and b, that is 2.625 and 2.75. So next I will go for the fourth approximation, that is x4, the 2.6875. So that is, I can see that x3 and x4 are approximately same. So I have to stop the process. So if you want, you can continue, or you can just simply you can stop the process. Why? Because the values are approximately same. If you want, you can stop the process, or if you want, you can continue the process. So you will get slightly different answer. If you do plenty of other approximations, you will get a slightly different answer based on the this equation. So therefore, the given root, the root for the given equation is 2.687. So I have stopped this problem. Why? Because x3 and x4 are approximately same. I have stopped the problem. So therefore, the root for the given equation is 2.687. So this is the answer on this. So this fourth problem is very important. He has given university has given many times this problem. So fourth problem is very important. So next, the fifth problem is, this is also a transcendental equation which contains trigonometric value. So I have given the trigonometric value. So f of 0 is less than 0, f of 1 is greater than 0, so root lies between 0 and 1. So I have taken the first approximation x1 equal to a plus b by 2. I have put the x1 value 0.5 in the given equation. I got f of x1 greater than 0. So I want less than 0, so f of 0 is less than 0. Therefore, the root lies between x1 and 0. So next I will go for the second approximation. So x2 equal to 0.25. So next to f of x2, I have put this value in the given equation. Next I will got x2 greater than less than 0, and I want a greater than 0, so f of 0.5 is greater than 0. So therefore, the root lies between x2 and 0.5. Next I will go for the third approximation. I will see that these two x2 and x3 are totally different, so I have go for the other iteration. So f of x3, I have put this value f of x3 greater than 0, f of x2 less than 0, therefore the root lies between 0.375 and 0.2. Next, I will go for the fourth iteration. I got 0.3125. So these two are slightly different. So if you want, I can stop here. But I will see that whether the other approximation is nearer or not. So I have gone for the fifth approximation. So in the fifth approximation, I have got 0.34. So I can see that the x4 and x5 are approximately same. That means 0.31 and 0.34 are approximately same. So if you want, you can continue, or otherwise you can just simply stop this process and you will get the answer. So I am having x4 and x5 are approximately same. So the root for the given equation is 0.3432. So this is the answer for the given problem. So this is how we are going to do the bisection method. So these are the problems of bisection method. So we can do plenty of problems based on the bisection method. Here I have given extra problems based on the bisection method. So you can solve all the problems based on the intermediate value theorem and fundamental theorem of algebra. You can solve all problems. So this is the homework problems I have given for you. So you can solve the problems. I have done the 5 problems for you, and you have to do the remaining problems. You have to practice these problems. So if you are having any doubt, you can call me. So this is the model, or this is the method on the bisection. So this is about the bisection method, the working rule and the problems on the bisection method.